Hello, and welcome to this video lecture. In this series of video lectures, we have been looking at decimals. In this video, we will talk about terminating decimals and repeating decimals. Let's talk about terminating decimals. A decimal is said to be terminating if it has a finite number of decimal digits. That is, if the number of digits to the right-hand side of the decimal point is countable. Fractions that have only 2 and/or 5 as the prime factors of their denominators will result in terminating decimals. For example, 1/2 is equal to decimal 5. 1/5 is equal to decimal 2. 21/100 is equal to 21 whole over 2 squared times 5 squared, which is decimal 21. Let's talk about repeating decimals. A decimal is said to be repeating if it has an infinite number of decimal digits that repeat some or all the digits continuously at regular intervals. Fractions that have prime factors other than only 2 and/or 5 at their denominators will result in repeating decimals. For example, 1/3 is equal to decimal 33333, and so on. In this case, 3 is repeating. 8/45 is equal to decimal 16161611, and so on. In this case, 16 is repeating. 3/7 is equal to decimal 0428571. 428571. In this case, 428571 is repeating. To convert a fraction to a decimal, we divide the numerator by the denominator using long division. If the denominator of the fraction has only 2 and/or 5 as its prime factors, we can easily convert the fraction to a decimal by manipulating the denominator to be in a power of 10. Remember to perform to the numerator any action performed on the denominator. For example, follow learning note and read this same type for below inquiry. Let's convert 9/50 and 5/54 to decimals. 9/50 equals 9 whole over 2 times 25 equals 9 whole over 2 times 5 to the power of 2 equals 9 times 2 whole over 2 times 5 to the power of 2 times 2 equals 9 times 2 whole over 2 to the power of 2 times 5 to the power of 2 equals 18 whole over 2 times 5 whole to the power of 2 equals 18 over 10 to the power of 2 equals 18 over 100 equals decimal 18. As you can see, the denominator 50 can be written as a product of its prime factors as 50 equals 2 times 5 to the power of 2, which means that it is only 2 and 5 as its prime factors. Thus, we can convert the denominator to a power of 10 and easily change the fraction to decimal. 5 whole over 54 equals 5 whole over 2 times 27 equals 5 whole over 2 times 3 to the power of 3. Since the denominator, 54, which can be written as a product of its prime factors as 54 equals 2 times 3 to the power of 3, has 3 as a prime factor. Thus, 5/54 is a repeating decimal, and we can only change it to a decimal using long division. 500 divided by 54 is equal to decimal 09259 recurring. That is, 5/54 equals decimal 0959259 recurring. equals decimal 0925 recurring, which means that the decimal digits 925 are repeating at regular intervals. To convert a terminating decimal to a fraction, we divide the number without the decimal point by a power of 10, equivalent to the number of decimal digits in the number. For example, follow learning note and read this of same type. Let's convert decimal 22 and 3.5 to fractions. Decimal 22 equals 22 whole over 10 to the power of 2 equals 22 over 100, which equals 11 times 2 over 50 times 2. And by canceling out the 2's, the answer becomes 11 over 50. Here, decimal 22 is a terminating decimal with 2 decimal digits, that is, 22. We then divide decimal 22 without the decimal point, that is, 22, by 10 to the power of 2. 3.5 equals 35 whole over 10 equals 5 times 7 over 5 times 2, which when you cancel out the 5's, it becomes 7 over 2. Here, 3.5 is a terminating decimal. With 1 decimal digit, that is 5, we then divide 3.5 without the decimal point, that is 35, by 10 to the power of 1. To convert a repeating decimal to a fraction, we first let the repeating decimal be x. First, we multiply both sides of the initial equation by a power of 10 that will make the last digit of the first set of the repeating decimal to be at the left-hand side of the decimal point to get one equation. We also multiply both sides of the initial equation by a power of 10 that will make the first digit of the first set of the repeating decimal to be at the right-hand side of the decimal point to get a second equation. We then subtract the second equation from the first equation. Then, make x the subject of the formula to get the required fraction. For example, let's convert decimal 454545 recurring and 1.2272727 recurring to fractions. To convert decimal 454545 recurring to fraction, we first let x equal decimal 454545 recurring. Next, since the repeating decimal digits are 45, we multiply both sides of x equals decimal 454545 recurring by 100, so that the decimal point will be after the last digit, 5, of the first set of the repeating 45. That is, 100x equals 45 decimal 454545 recurring, which we take as first equation. Next, since the decimal point is already before the first digit, 4, of the first set of the repeating 45, we take x equals decimal 454545 recurring as second equation. Next, we subtract the second equation from the first equation. That is, 100 times x equals 45.45 recurring whole minus x equals decimal 4545 recurring, which implies that 100x minus x equals 45.454545 recurring minus decimal 454545 recurring, which gives that 99x equals 45, which means that x equals 45 over 99 equals 5 times 9 over 11 times 9 equals 5 over 11. To convert 1.227 272727 recurring to fraction. We first let x equal 1 decimal 2272727 recurring. Next, since the repeating decimal's digits are 27, we multiply both sides of x equals 1 decimal 2272727 recurring by 1,000, so that the decimal point will be after the last digit 7 of the first set of the repeating 27. That is, 1000x equals 1227 decimal 272727 recurring, which we take as first equation. Next, we multiply both sides of x equals 1 decimal 2272727 recurring by 10, so the decimal point will be before the first digit 2 of the first set of the repeating 27. That is, 10x equals 12 decimal 272727, which we take as second equation. Next, we subtract the second equation from the first equation. That is, 1000x equals 1227 decimal 272727 recurring minus 10x equals 12 decimal 272727 recurring, which implies that 1000x minus 10x equals 1227 decimal 272727 recurring minus 12 decimal 272727 recurring, which gives that 990x equals 1215, which means that x equals 1215 over 990 equals 9 times 5 times 27 over 9 times 5 times 22 equals 27 over 22.